Hi all. In this video, we see a paper titled Deep Driving. So this paper says about there are usually two major approaches for a vision-based autonomous driving system. One is a mediated perception approach. The other one is a behavior reflex approach, which directly map an input image to compute a, steering angle or a action through a regression like convolutional neural networks. So this paper introduces a third paradigm, namely a direct perception approach, in order to estimate not directly the steering angle, some kind of information which is utilized then further into a controller to compute the steering angle. So this is something falling in between these two extremes like mediator perception and behavioral effects, which we will be giving a brief description now. So mediator perception approach is something in vision based uh, systems where it uses visionary information to estimate the objects around vehicles, and also it gives the lane informations, the principal lane and the left lane and right lane informations, traffic lines, pedestrians, and all those informations are collected together to make a world representation which is taken into account by the controller to in order to compute the steering output. So usually the AI is considered to be as a controller which take this information to in order to compute the actions for the autonomous vehicles. But since these actions from these autonomous vehicles are low dimension, namely steering and pedaling and braking, like two dimensions like steering and acceleration, linear and angular accelerations, or linear and angular velocity. This whole information coming from this mediator perception approach is quite complex and seems to be unnecessary. And what it would be, for example, mediator perception involves in detecting a bounding box of a car in front, and that bounding box is further utilized by the other algorithms to estimate the distance of the car in the front, and how based on that distance it computes to deaccelerate or to make a lane change. So yeah, why not this information like how many distance in front of the object can be directly computed using the visionary data instead of making a boundary box and all those unnecessary calculations. Moreover, relying on systems like sensors like radar and GPS are seems to be very not reliable, and the simpler approach would be to make use of this visionary data to compute those affordance around us in order to give that information to the controller for the computing the steering. The other approach is named to be as a behavior reflex approach. In this approach, instead of making all those world representations, those pixel-based representation is directly taken into the controller in order to produce and driving actions like steering and pedaling. So this things not from this advent of this deep learning. It has been around 80s where they use the artificial neural networks to directly take the image data to compute the steering angles. And further, some of the papers like uh, called Dave and Dave 2 from NVIDIA, all those paper have given some kind of direct perceptions approach where end-to-end learning was implemented using a convolutional neural network where this direct pixel image is taken to compute the steering output. So one of the disadvantage is like a human when drive seeing a particular scenario, the what actions would be taken is not seems to be like a unique. It different driver takes a different actions based on his own experience. So it seems to be like it's not a unique solution, it's an ill posed problem that would be confusing. For example, our same image is given and different driver takes a different actions. What types of actions would this learning model will build up if we are giving the same image with different actions from different humans? This is one thing. Now another thing is, since it's a low level and giving this cannot give some kind of a big picture. like how to make a lane change, what kind of steering angle to do, like kind of temporal dependencies, all it's very difficult to capture, and it seems to be very unnecessary. And moreover, if a particular image is given, what part of the image will give you relevant informations, and what part of the information has to be given an big attention is also very difficult and too weak to force the algorithm to learn these critical informations. So to overcome these two setbacks, this author desire to learn representations that predict the affordance like driving actions, called the direct perception approach. This third paradigm is to learn mapping from an image to several meaningful indicators of the road situations, like relative angle of the car to the road, distance to the lane markings, and distance to the cars in current and adjacent, give some meaningful representations around the world representations, and that can be given to the controller to make the car to drive smoothly. Here, this model, these affordance are being output from convolutional neural network framework. Using the training data sets comes from the video game simulator called Talks, and also they have also used utilized some real human and driving data sets from KITTI data sets, and try to produce this affordance output from the convolutional neural networks. So related work is most, we know that most of these autonomous perception systems are mediator perception approach. They try to make lane detections and the bounding box for the cars in front, and to represent the lane they make some kind of a spin interpolations. And one of the disadvantage what we mentioned is the informations are very huge, and also they have suffered from kind of inaccurate informations, and they also fails to give some kind of a localization which depends upon external sensors like GPS, which is not a reliable one. So in this one, again coming to the other one, that behavior reflex has many papers. One among the papers like I introduced like 1980s, and some of the recent works they have used reinforcement learning approach to make directly the action predictions from the pixel data. As I mentioned, that Dave is one of the system they build using convolutional neural network directly from the images to compute the steering angles. And these are some of the related work done. And how does the affordance been the conventional train to bring this affordance as an output, like they take humans to drive the car, and those data are taken into as a testing, and while driving they they timestamp to what kind of ground truth value, like what is the angle of the car, and what are the cars around, what are the distance of the car in front, and all those informations are being recorded for that particular pixel data, and those ground truth tables are collected and also utilized for the training. Even for testing, those ground truth tests are collected, and further that also been utilized for the testings. So the what are the affordance been is given in this figure 4, like lane marking to the left, lane marking to the right, and left lane marking to the left, right lane marking to the right, and what are the objects in the front. All those, these are the affordance given in the figure 4, that is almost like 13 affordance, and what kind of actions to be taken based on that affordance is also being given this logic. While autonomous driving, why we collect these affordances, and if the affordances is something that this kind of fuzzy logic information is being utilized to compute which mode that it has to go, whether it has to lane change mode, or it has to adapt the speed, or it has to go in a normal cruising speed, is based on the information collected through this affordances is given to into this control logic, which is represented in the figure 5. So this is the steering command, which is something related to the informations collected through the affordances, like how much distance is from the center and how much is the road width. All those things are how much angle with respect to the road length, that car length that this use. This is some kind of a coefficient which varies from using different car conditions. So, and also if there is something in a car in front, whether it has to be adapted or it has to lane change also based on line. If it has to be adapted, what speed it has to adapt and what is the maximum speed and how the exponential decay has to be set is based on these equations too. So the implementation, I said that convolutional neural network is the one which is implemented in a Cafe C++ library and use the standard Alex network, which has five convolutional layer and fully connected layer. This is something five convolutional layers is something presentation of the feature extraction, and this is for making a regression for the steering angle calculations and Euclidean loss, the standard loss is being used, and these are the sum of kind of output dimensions from each layer, and these are some of the things they have set for collecting the training sets, and and these are some of the learning during the training stage, what learning rate, what is the mini batch, how the random selection have, how many epochs have been utilized, all those informations are given. And once this trained things, it was evaluated comparison to the different uh, net where behavior reflects and direct mediator perception behavior reflects that it has to go for a direct maps, so it seems to be like while going along the free lane it seems to be working, but if there is a multiple vehicles or not, it has fails to make some kind of make a logical decisions to adapt the speed or overtake, and it has the host car has collided in a multiple stages. Mediator perception approach, again I said that it has some kind of a and heavy unnecessary calculations, and this Caltech linear is relatively unreliable and weak formulations, and it didn't perform as similar to the direct perception approach which we were trained through these convolutional neural networks. So they also tested using the real world data using Getty data. It seems also performing well as per this report on the table 2, and and I also compared with some kind of a baseline model, which again they ultimately they says that this seems to be performing reasonably well in real world data as well. Well, visualizing the neurons of the training or during the training stage, they could easily visualize the what kind of patterns are being observed in the neurons, that it gives a strong correlation with the cause host heading location of the landmarkings and the traffic around the cars. So it seems to be that author believe that convolutional has developed a task specific features for the driving. So conclusion is this author has entered into a different paradigm, not going into a conventional or behavior reflex or mediated perception. Third, a direct perception to compute the affordances around the car informations to in order to compute the steering through the controller AI agent. So and that computation is carried out using the convolutional architecture to estimate those affordances for driving actions instead of passing the entire scenes to or directly mapping an image directly to drive commands. So an experiment shows that the approach seems to be well promising in both in virtual and the real world environment. Thank you.